All right, so welcome to the second module. This module, we are learning about arrays. So arrays, as you saw in the preview video before, are actually these very useful basic data structures, which combine multiple variables into one. So in this video, this first video, we are going to learn about how to create an array, which is fairly straightforward. Suppose I want an array of integers, basically a single variable that's going to hold 5 integers. I do it like this. Int array is equal to new int 5. Now, don't worry if you forget this the first couple of times. I basically had to, like, through my entire undergraduate, I kept forgetting at the beginning of a new semester, how do I declare array again? It was a pretty terrible student. But anyway, now I've got it because I've, practiced, which was the key crucial thing I forgot to do as an undergraduate. So int array is equal to new int array 5. So this is saying that basically we want an array of size 5. The array notation can go either right after the integer, or it could go over here. Either is fine. It just makes more sense to me to say, hey, this is a integer array equal to new integer 5. So this is specifying we want one of size 5. Now we can go ahead and print out what we've gotten, and we get gibberish. Actually, we get open bracket I at symbol 7C30A502. Do the same gibberish when we run it again. Let's find out. Yeah, seems like it. What if we do something over here like int? What if we make a string first? String s is equal to gibberish. The same gibberish now? Yeah, it is. Interesting, that. What if I made it an array of 6? Is it still gibberish? Still the same gibberish. Interesting. So, it's not completely random gibberish, but what are we getting? We are saying... What is this? Well, it's not actually gibberish. What it's saying is that we've got this bracket over here, which means array, and then I for integer, so an array of integers, and it's saying it's at memory location 7C30A502, which is a hexadecimal memory address. So that's interesting. But that doesn't really give us useful information, right? If we populate this array and we get a bunch of memory addresses, not very useful for us. So what we're going to use instead is that we're going to use a useful utility class called arrays. It's a utility class just like ints have the integer class, doubles have the doubles class, arrays have the arrays class. So here what we're going to use is a useful method called the arrays.toString method, which given an array will turn it into an actual, usable string for us. So if we run this, we get 5 zeros, which makes sense if you think about it for a second, right? First off, there's 5 of them. That part makes sense, right? And then them being 0, well, they need some value in order for us to, to start with. We just created 5 of them. So what should the default value for an integer be? And 0 is as good as any, to be honest, right? But it makes sense. So we've just created, so when you create a new array, you get a bunch of what we call 0 values. So for integers, that'll be 0.0. For doubles, that will be, for integers, it will be 0. For doubles, it will be 0.0. For booleans, that'll be a bunch of falses. And for anything else, it'll be nulls, which means, for objects, any objects like strings and scanners, this will be null, which means this thing doesn't actually exist. So, int array is equal to new integer. And we've created 5 integers. There's a different way to create an array of 5 integers, which is that we could do this. 1, 2, 3, 4, 5, right? And this will literally declare the array 1, 2, 3, 4, 5 for us, which is useful. It does have some restrictions. First off, if I can only use that when I'm first creating an array. So if we go back to here, I can just split this up into 2 statements like I could anything else. But I can't use this format. I can only use that when I could only use that over here in the first line when I would have initially created this. So that's just a restriction to keep in mind. Most of the time we just do use the new int, and then however many you want in there. Okay. So the next, what about, and we can create an array of anything. We could create an array of doubles, as I mentioned, right? R dir is equal to new double array, 10 doubles. Let's go ahead and print out, if I'm making an array, got to put in the array notation there, right? And we're going to go ahead and print out dir for us. And a bunch of 0.0s. Let's go ahead and do string. I'm just making up terrible names for these things. Sir is equal to new string. And let's go ahead and just say it's an array that could hold 2 strings. So we'll print out sir, and that will give us an error because I forgot a semicolon, right? I make mistakes all the time, and I do not take them out in post because that is actually less useful for you than to see me going through and correcting these mistakes. Every programmer makes mistakes. If somebody says they program without making mistakes, they are lying. I can count the number of times I've successfully completed an assignment without any mistakes from the beginning to the end, where I sat down, started typing it out, and it came out. And I could count the number of times that has happened on a blind butcher's hand. So, 2. Now, as far as putting new values in arrays go, that's actually not too hard to do. What we use is that we use this subscript notation, this bracket notation. So let's go ahead and work with just our array of integers for right now. So we'll comment these out just to be able to focus on them. So let's take a look at this statement. R0 is equal to 5. System.out.println arrays.toString r. 50000. Straightforward. And what this means is that we are going to store 5 where? In the variable array at index 0. So if I wanted to store something at index 3, which is this 4th value over here, I would just say simply index 3 is equal to whatever integer we can put in. Takes any integer. Valid, right? Any valid integer. So the minute I go up to, the minute I add another 0 would be an issue. It's fairly straightforward to put things into arrays. Right? For doubles, same deal. I can put in 0 is equal to 1234.5. You don't actually have to ever start out with the first index. You can put them wherever you want. 0001234.5, right? That's no problem whatsoever. We can retrieve values from the array using the exact same notation. So I can go ahead and let's go ahead and actually do this with a string now, just to show that we can do it that way. So srr is, we're going to go ahead and put index 0, and we're going to put hello in there, and then string s is equal to srr 0, right? So we're going to store hello in there, and then we're going to take the memory location that's stored in index 0 of srr and put it in s, and now we'll go ahead and print out s. And we get hello. Couple of last things to note for this. First, if we grab index 1, we're just going to get null because we haven't declared it yet. However, if we go for index 2, we get an error, an array out of bounds exception, right? This is too long, meaning it has 2 valid indexes, 0 and 1. So if we go for index 2, not going to work. On the other hand, same thing with basically if we try to store something, right? If I try to store index 5 at index 100, I get an array out of bounds exception exact same way. Why? The reason being is that once you create an array, you cannot change how big it is. This is because an array is an allocated giant block of memory. So we just allocate all the integers that would go into the array, all that memory for it at once. And if we needed to extend that, then we would have some issues. If we tried to extend that, we might go into memory that's already being used, and that ends up being a bit of an issue.